What if you could give a plant its own personal life support system? A tiny, self-contained lunchbox for its roots that could turn barren desert sand into a little patch of paradise. Well, that's the wild idea behind the self-fertilizing root cassette. It's a plug-and-play module that could completely flip the script on how we do agriculture in the world's driest places. So let's dive in and see how this thing is supposed to work. So how do you make a desert bloom? I mean, for centuries, the answer has basically been brute force, right? You dump massive amounts of water and tons of fertilizer on it. But this concept asks a different question. What if, instead of trying to change the entire desert, you could just create a perfect little micro-ecosystem right where the plant needs it most? And to really get why this solution is so clever, you first have to understand the core problem. See, growing things in a desert isn't just about the lack of rain. It's a fundamental issue with the soil itself. You're fighting a battle against physics and biology every single day. Yeah, take a look at this comparison. On the left, you've got arid soil. It's basically a sieve. It holds almost no water, less than 3%. Whatever moisture you put in either drains right through or evaporates in the sun, taking any nutrients with it. But on the right, you have fertile soil. That's a completely different world. It's a sponge for water and a pantry packed with nutrients. The whole challenge is figuring out how to bridge that massive gap. So how do you fix a problem like that? Well, this is where the elegance of the solution really shines. Instead of trying to terraform an entire landscape, which is incredibly expensive and difficult, you just create a tiny island of fertility right where the plant is. It's a plug-and-play approach. And here it is. It's officially called the Weathering Hypha Cassette, or WHC for short. But honestly, the best way to think of it is as a lunchbox for plant roots. That analogy is just perfect. It's a completely self-contained unit that gives a young plant everything it needs to get a fighting chance in a really hostile environment. And don't picture some huge, heavy piece of machinery. We're talking about a small 2-kilogram module. That's it. You basically just dig a small hole, plug this life support system into the ground right underneath where you're going to plant a seedling, and you're good to go. All right, so what's actually inside this little lunchbox? This is where the real magic happens. It's not just a box of dirt, it's a combination of clever material science and biology, a kind of high-tech living sandwich. Check out this breakdown of the 4-layer system. First, you've got the sponge layer. It uses something called liquid nanoclay to basically coat sand grains and force them to hold on to water. Then there's the living web layer, which is a network of fungi that acts like a digestive system, releasing acids. Why? Because those acids go to work on the 3rd layer, the nutrient layer, which is full of crushed basalt rock. The fungi slowly dissolve the rock, unlocking minerals for the plant. And the whole thing is held together by a biodegradable smart frame. But here's the absolute coolest part. This whole system is alive. It's packed with a crew of microscopic workers. You've got bacteria that produce a natural water-retaining slime. You've got those fungi which act like tiny fungal miners breaking down rock. And to keep them all alive, the cassette includes a food source and even tiny microcapsules to protect them from heat and salt. Okay, this all sounds amazing on paper, right? But a cool idea is one thing. Proving it actually works is something else entirely. And that's what's great about this proposal. It's not just a concept. It's backed by a really rigorous plan to test it every step of the way, from the lab all the way to the desert. And you can see that plan laid out right here. It's a really logical 3-phase roadmap. Phase 1 starts small, in the lab, just testing the basics in sand columns. Once that's proven, you move to Phase 2 in a glasshouse, growing actual plants to see how they do. And then, the final boss, Phase 3. A real-world pilot test out in a desert environment like the Negev or in the UAE. This quote from the source material really nails it. This isn't just some vague dream. It's a field-serviceable modular concept with explicit KPIs and a pilot roadmap. And those KPIs, key performance indicators, are crucial. They set clear, measurable goals that this thing has to hit to be considered a success. And here's the first big KPI. And honestly, this is a total game changer. That arid soil holds less than 3% water, remember? Well, the target for the WHC is to boost that to at least 18%. We're talking a 6-fold increase. That is literally the difference between life and death for a plant in the desert. The next big goal is all about fertilizer. Because those fungal miners are unlocking nutrients directly from the rock, the cassette should dramatically reduce the need for industrial fertilizers. The target is to cut nitrogen fertilizer use by at least 20%. So let's play this out. Let's say it works. They hit their targets. What's the real-world payoff? Well, it's huge. It tackles two of the most critical issues we face, the economics of food production and the climate crisis. First up, let's talk money, because that's always the big question, right? The estimated cost for the materials to make one of these cassettes is just $12. Think about that. This is specifically designed to be an accessible, affordable technology, not some expensive gimmick. And for a farmer, that $12 makes a ton of sense. The money they'd save on buying fertilizer alone means the cassette could pay for itself in 2 years or even less. That makes it a really attractive and, frankly, common sense investment. Okay, now for the climate angle. Making nitrogen fertilizer is an incredibly energy-intensive process that pumps out a lot of CO2. By cutting back on its use, each one of these little cassettes could prevent about 45 kilograms of CO2 equivalent emissions from ever reaching the atmosphere. Now multiply that by millions of units, and suddenly you're talking about a serious impact. So let's just put all the key numbers in one place. We're looking at a $12 unit with a 2-year lifespan that pays for itself and helps the climate. When you see it all laid out like this, you really get a sense of just how powerful and well thought out this concept is. And the potential uses go way beyond just traditional farming. Imagine using these for huge agroforestry and restoration projects, or to create green shelter belts to stop the spread of deserts. You could even use them to make vertical gardens possible in arid cities. This could be a foundational tool for a whole range of greening initiatives. And all this brings us to one final, powerful question. You know, when we think about reversing desertification, we usually imagine these massive, landscape-scale projects. But maybe the answer isn't just about going big. Maybe it's also about being small and smart. Could targeted, intelligent living modules like this be the actual key to restoring the world's arid lands? It's an idea that truly has the potential to change our planet.